Hello, everyone, and welcome to our webinar, Getting More Out of Virtualization Faster with XAP. Today, our EVP of R&D, Guy Neopaz, will introduce the latest enhanced support and integration for VMware. Please feel free to send us your questions during the webinar using the chat tool. We will respond to your questions during the webinar, as well as at the end during the Q&A session. Also, during the webinar, you will be prompted with a few polling questions. So, once these questions come up, simply choose your response, so we can learn from each other about our opinions and preferences. I wish you an enjoyable and interesting webinar and urge you to fill out our survey at the end of the webinar. Your input is very important to us. I'll now pass the mic to Guy Neopaz.
My name is hello, and thank you all for joining. My name is Guy Neopaz, and I'm the EVP of R&D at Giga Spaces. In this session, we'll talk a little bit about Giga Spaces offering for VMware, and the new offering and its values will be introduced. So a little bit of background about Giga Spaces. Giga Spaces is around for software company which is around for almost 10 years. We have a couple of hundred customers with various industries. Giga Spaces' goal is to, and mission is to take many computers and combine them into a single platform where our customers can build their application services on top of that. Giga Spaces' roots come from the financial services, and many of the financial services institutes had these challenges a few years ago. Now it is more common across enterprises, internet, large websites, and other industries. So when we talk a little bit about cloud computing, which is by far the most hyped term these days, we're talking about the ability to take commodity hardware and consume these hardware capabilities based on the need, meaning being able to allocate resources on demand from a pool of resources and being charged for these resources by the CPU or by the hour for a variable amount of dollars or money. The benefits, of course, in adopting virtualization and cloud computing, the first and foremost is cost reduction. The cost for doing business or IT business is less, as the model that we're using is different. We're paying only for what we are using. Also, cloud computing favors automation in favor of labor, in favor of manual labor, which reduces the cost as well, and fixed cost is being turned into variable cost, which basically means we're paying for the value that we're getting out of the infrastructure technology. A second value most talk about is the business agility. The ability to focus on what's important for the business and focus mostly on that and not put many of the resources on handling low-level infrastructure constraints. With the capability of computers on demand, obviously scalability can be achieved. Scale-out model where we're adding more compute resources based on the requirement by our customers, and it is in many cases considered as unlimited capacity. Obviously there are many more, but I'm not going to go into that. So here is we want to do our first poll. So Maya? So I guess
Hi, sorry, now is the time for our first polling question, and I'm going to launch the question now. Okay, so what is or are your key drivers for using virtualized technologies? Cost reduction and IT efficiency, business agility or growth, business continuity, business innovation, or process automation and improvement. Okay, I see we have 50% voted. So those of you who haven't responded yet, please let us know what you think. Okay, 64% have voted. Okay, I'm going to close the poll in 5 seconds. And I'm closing the poll. So here are the results. We can see that the key driver for using virtualized technologies, 80% of you feel that cost reduction and IT efficiency is the key driver. Okay, Guy, we're going to get back to you.
Thank you. So I see that most of us agree that cost reduction is the #1 driver for cloud computing and virtualization. So here is an overview slide of the various layers and players within virtualization and cloud computing. It is usually divided into 3 sections: the infrastructure as a service, platform as a service, and application as a service. Where in infrastructure we find players, and the most notably for public cloud is Amazon EC2. We've discussed last week about Giga Spaces, with GoGrid. In the platform as a service players, we find the Google App Engine, Azure services from Microsoft. And in applications as a service, the most notably Salesforce, and other applications like Gmail are available too. Today we're going to focus on the infrastructure as a service and the platform as a service capabilities. So first I'm going to talk about operating system virtualization. So I guess we all aware that operating system virtualization comes from an idea of taking one large physical machine and separating that into multiple virtual machines, which will take advantage of the resources of this machine, which are usually not being used. So taking one large machine and breaking that into several virtual machines will reduce the cost of operation of this machine, improve the ROI of that, improve the utilization, and in many cases will simplify the maintenance of machines as machines become disks and processes and not necessarily physical infrastructure. So this is where VMware started their virtualization effort, and this is where they focused most of their effort through the past few years. Giga Spaces comes from a different angle. In Giga Spaces, we're talking about middleware virtualization. The idea is to build middleware services which are span across multiple machines. For example, a data grid which is running on multiple machines, and creates a logical middleware service which is consumed as a single service by higher level applications. Another example is event processing service and parallel processing service, and obviously a combination of all. And on top of that, as I said before, running applications which can be considered cloud applications by consuming virtual joint solution, and why does it make sense? So I'm going to show the reference arcs that are spread across the world. Sorry. On top of that, there is the APIs and the multiple cloud services. For example, data services are available through the Amazon SimpleDB, messaging through the Simple Queuing system, file processing is addressed through Elastic MapReduce, and various SLAs are supported through the Amazon Autoscaling. So to map that to the joint solution, when we're the image capabilities, the ability to start and stop machines through APIs, and various management and monitors at the virtual machines and physical host level. Giga Spaces adds the middleware services capabilities, which is through the Giga Spaces data grid, Giga Spaces event-driven capabilities, and parallel processing and MapReduce. And on top of that, Giga Spaces also adds the capability to deploy applications which are movable through the life cycle of the Elastic cluster. So to try and make it clearer, Giga Spaces' focus is on the middleware and the platform, whereas VMware focus is on the infrastructure as a service. And by showing that in this picture, we see how Giga Spaces solution complements the VMware vSphere to enable building a complete private cloud within the enterprise today. For example, I just want to give an example of what it means middleware as a service as opposed to standard enterprise data grid. So the user will want to create a data grid with the following SLAs. The minimum data which will be hosted is 10 gigabytes and the maximum is 100 gigabytes. Another application will use the same data grid with different characteristics. In case of load, additional machines will be added to support the requirement of more data or more requests. When there is a failure, the system will automatically recover through the integration between the ability to create new machines and to deploy additional data grid components on it. And from a configuration perspective, it is as simple as defining through an API the following XML. Create a data grid with minimum size of 10 gigabytes, maximum 200 100 gigabytes, which will auto-scale. That's all there's to it. And this is what is different between middleware as a service and standard enterprise data grid. Just to complete the picture, Giga Spaces platform, the XAP platform, supports both internal clouds, external clouds, with various capabilities which can be consumed and in pieces. Not necessarily, you don't necessarily have to have the full XAP platform. And the XAP platform enables building many types of applications focused on Java and J2E and .NET, but not only.
Okay, guys, so now I will launch our second poll question. What type of applications are you planning to move to a virtualized infrastructure? We'd love to hear your input. Okay, we have 75% voted. Okay, we have 81% voted. I will close the poll in 5 seconds, so please tell us what you think, those of you who haven't voted yet. Okay, I'm now closing the poll, and let's share our results. So we see that on the first place we have internet applications, 54% of the people. Okay, Guy, can you please continue?
Thank you. So Giga Spaces solution for VMware vSphere is designed to enable you who implement private cloud using the VMware technology to be able to move as many applications and in many ranges onto the private cloud today. The offering is a separate package which contains prepackaged VMware images with Giga Spaces installed and tuned on them. It contains various middleware services for data, event processing, and parallel processing, similar to what we saw earlier on the slide which compares the Amazon public cloud and the joint solution. Predefined SLAs for auto-scaling and fault tolerance, which can be extended, a web API to control all of that, and a web dashboard to monitor and get information of what's going on within the system. As I said before, the value of the joint solution, the first and foremost, is to be able to run as many applications as possible on the virtualized environment. It is clear to us that the projects and efforts within the enterprises to implement private clouds are not going to be simple and will take significant resources from the enterprise who will adopt private cloud. The next challenge will be to on-ramp as many applications onto the platform to return the investment of virtualization. And we believe that with the Giga Spaces solution, you will be able to implement as many applications on the private cloud more than you could have done without the Giga Spaces support. As Giga Spaces supports many standards, specifically Java and .NET, but not only, it is applicable for a very wide range of applications coming from high-end type of systems, through internet systems, through smaller type of system. It contains capabilities for on-demand dynamic scalability, which means adding and removing resources on a needed basis. It is designed for high performance and resilience. And it also addresses a higher level of compute sharing across the various systems, as I showed before, ability to share data across a single data grid, ability to compute or share other capabilities across a single set of resources. In addition, we have in mind the various ranges of cloud adoption within this solution. Some of the applications will only want to be able to mount or take existing application and just make sure that they run accordingly with minimal changes on the private cloud. Others will try to enhance the capabilities by supporting, for example, SaaS models, which requires higher level of scalability, better performance, security, which enables multi-tenancy, and so forth. And obviously, with the new cloud capabilities, businesses can innovate and build a new type of infrastructure or business systems that can take advantage of the dynamic capabilities and the new cost structure of cloud. All that can be achieved with the combination of VMware vSphere and Giga Spaces solution. And one last benefit, which is, you said before, most of you voted before, that cost reduction is the #1 driver. Giga Spaces increases the cost reduction or reduces costs even further than just adopting virtualization. Usually in Giga Spaces deployments, due to the fact that the product is very efficient for multi-core and multi-processor environments, Giga Spaces customers are, in many cases, reducing 80% of their hardware investment. In addition, the ability of a complete automated system with predefined SLAs enables reducing configuration and labor costs. The model of scale out, which means that once a new resource is added, a new computer is added, it shares the load with its other peers, is significantly cost reducing capability. And the fact that Giga Spaces supports a deployment model which is not only at the VM level, where in vSphere you can start and stop machines, in Giga Spaces you can also start and stop processes within the virtual machine, which can also give you a finer grain of control over the capabilities and the deployment of the system.
Okay, so before we move to our live demo, we are going to have a third polling question. So please tell us, in relation to your production applications, what percentage are planned to leverage virtualization technology in the next year? Okay, we have 50% voted. Come on, please let us know what you think. Okay, 10 more seconds and I'm closing the poll. And I'm closing the poll. Okay, let's share our results. We have a tie here. 30% of you said less than 10% and 30% chose more than 50%. Okay, Guy, can you please continue to the demo?
Thank you. So first I'm going to switch to the Giga Spaces UI, and I'm going to start the demo, let it start rolling, and then explain a little bit about that. As it starts virtual machines, it takes 4 minutes to start fully function. Okay. Switch back to presentation. Okay, so here in this demo, we're taking the standard Spring Pet Clinic that comes with every Spring distribution. It is a web application that does some databases requests. The concept is around pet clinic and vets and veterinary and appointments and so forth. The domain of the application is not that important for this demo. However, what's important is that it is a standard, super popular Spring type of application. And instead of accessing the database directly, the Spring application, which is deployed on the Giga Spaces web container backed by Jetty containers, is accessing the data grid as a service instead of accessing the database. Once we'll increase the load, a new web container with application will be automatically provisioned. The load balancer will be automatically provisioned, and the data grid is going to be accessed through the system. In addition, then we're going to drop the database, and we'll see that the system continues to work. And database in this case can be any backend non-virtualized information system, which cannot be scalable or dynamic as we need. And in many cases, we do not foresee that so many applications will change in a short time frame. So this is the demo flow. Just to give you a hint, the modifications that we've done, excuse me, to the data access there in the pet clinic, we've implemented a new Giga Spaces clinic, which is the data access object, which comes a different data access object which comes with the demo. And instead of accessing the database directly, it accesses the in-memory data grid as a service instead. So this gives us the transactionality and the buffer and the scalability and the multi-tenancy that we need, that cannot be addressed currently by standard relational database. So I'm going to switch back to, I'm going to move to the vSphere client. Here you see, now you see on the left tree, excuse me, standard vSphere. We have two physical machines with multiple logical machines, which were not started once I started the demo. As part of the application deployment, those machines were started. I can switch now to the Giga Spaces interface, which demonstrated clearer. We see here 3 boxes. Each box is a physical machine, or sorry, it's a virtual machine. And we see that on these machines we have, just let me grab a pen for a second. We see here web container, and we see here part of the in-memory data grid. And now I'm going to access the application through a standard web browser, and we'll see that we are accessing the load balancer, which routes us to a Jetty web container. We'll add an owner. This goes, oops. This happens always just in demos. Let's try again, otherwise we'll skip it. Let's refresh everything and make sure that it goes to where it needs to go. I will try again. Okay, I see that now it works. I had to refresh the browser because it started from scratch. We can see that we can change the data, and the data is changed. Database, the in-memory data grid is accessed. And now, since I was doing so many activities, the system auto-scales. I'll switch just a second so you can see here in the vSphere view. I'm sorry that it's very difficult to see, but we can see that on the task list here, a new virtual machine was started as a result of a scaling factor. Here we just tune it to once we access 50 times the web server, it will start a new an additional component, but this is obviously not the tuning that we'll do on a regular system. So what's going on right now is that a new virtual machine is starting. Once it's going to be up, the system will auto-scale itself and provision the resources accordingly. In the meantime, I want to show you how I'm going to kill the database machine, and we'll see that the system will continue to work even if the database machine is down. So I'm shutting down the database machine. The database is just asynchronously configured. Switching back to this view, you can see that the machine here at the bottom left box was added. It's in IP 103. The system automatically reallocated components. It continues to do so. So the load across the system is even. And even if the database is down, still, if you will look for our product manager, again, we'll see that he's there. I can also change values. Instead of 15, let's put 90, and the system continues to work, which means that the in-memory data grid as a service is actually a fabric between the application and the enterprise information system, which is not as scalable or as available as the virtual in-memory data grid. So this concludes this part of the demo.
Okay, this is our final poll question. For those apps in your enterprise environment that do not leverage virtualization, what is the primary hurdle to adoption? Okay, we have 50% voted. This is the final question. We'd love to hear what you think. Okay, I'll close the poll in 10 seconds. Okay, I'm closing the poll. So let's see our results. %36% concerns with security and 36% concerns with ability to monitor and manage these applications. Okay, Guy, please continue.
Yeah, okay. Just before I jump into the roadmap, I see here a question which I want to address. You saw in the demo that we stopped the database, and now all the changes are within the in-memory data grid. Once the database is going to be back up, all the changes are going to be reflected in the database, and database state is going to be consistent with of the in-memory data grid. So just leftover from the demo. Okay, so with regards to the roadmap, so we're currently running a private beta of the solution, and a public beta will be released on the, or will be available pretty soon in as part of Q4. This will include the prepackaged VMware images, the predefined SLAs, and set of best practices for working with VMware vSphere and Giga Spaces XAP. We plan to have the solution publicly available in Q1 of 2010. It will also include the web API and the web dashboard, which I mentioned before. Currently scheduled for Q2 is integration with the vCloud API. The implementation currently is integrated with the vCenter APIs, and once the vCloud APIs will mature a bit and we'll get to a final stage, we're going to integrate. If it happens prior to Q2, we'll probably integrate it even prior to Q2. We plan to provide also a JPA API for the in-memory data grid. And Q3, the roadmap is for data center redundancy between various virtualized middleware components, and we plan to support additional data grid APIs which will enable switching between various solutions of virtualized middleware. To learn more about this solution, we have a web page available which is gigaspaces.com/VMware. We've just announced yesterday through a press release, and you can read all about this in this link. In addition, the solution is soon going to be available through the early access program of Giga Spaces, so you'll be able to find the things that you've seen in the demo just now. And the recording of this webinar will soon be publicly available on our website.
Okay, guys, thank you very much. We now have some time for Q&A. While answering those questions we've received so far, please feel free to continue sending us your questions, and please note that we will publish all Q&A later on. So the first question is, can you autoscale a precision data grid in 7.0.1?
The answer is, as part of XAP 701, we do not provide out-of-the-box autoscaling capabilities. However, all the building blocks are there. The admin API, which was published in 7.0, enables you to autoscale if you want to write a bit of Groovy code or Java code. As part of this solution, we will provide the autoscaling scripts and SLAs as part of this solution. The VMware Giga Spaces solution, which will also be modified later for additional virtualization technologies.
Okay, the second question is, when database is down, how does app access non-loaded data, e.g. lazy loading?
Okay, so this is a very good question. In this case, in the demo that we showed, we were talking about what we call all-in-cache type of scenario, where the data grid contains all of the data which is needed by the application in all times. If some of the data is not loaded prior to working, and the data store, which is not Giga Spaces, is not highly available, then obviously the application will suffer from downtime. So for this reason, in many cases, we think that you should have all the data. Obviously, not all the time it's possible, but all the important data stored within the in-memory data grid. And since the in-memory data grid is dynamically scalable and has almost infinite capacity, you can do so. We also plan to add support for combination of in-memory and disk capabilities. So essentially, it will mean that all data can be stored in the in-memory data grid and not just data which meets the capacity requirements.
Okay, the next question is, what role of GS Agent is loading additional virtual machines, GSCs?
All right, so this is a very good question, and I guess it refers to the GS Agent which was added in 7.0. So for those of you who are not aware of the GS Agent, the GS Agent is basically a gateway that we start in every virtual machine, which enables controlling the various Giga Spaces servers and components on the machine. So one role of the GS Agent is to be able to connect all the various Giga Spaces components automatically once the VM starts. The GS Agent is not responsible, however, to start virtual machines. We start virtual machines through standard, currently vCenter and future vSphere API. A combination of the process level that is provided by the admin API and the agent, and the VM level, which is provided by the vSphere APIs, is what enables dynamically adding VMs and on top of these VMs automatically capabilities. And if you recall, this is what I called before the fine-grained capabilities of process level control on top of VM level control.
Okay, the next question is, what's the new support on indexes and joins on the space?
Okay, so this is a good question, not directly related to what we've demonstrated today. I'll make a short answer to that. We've improved in recent releases both the index handling and the amount of memory that indexes consume. In addition, there is also improvement in the query engine to support better SQL queries. New features in this direction will be also available in Q1, which will enable even additional capabilities of dynamic indexing and more expressive query to objects within the space.
So the next question is, what impact does a VM have on critical low latency transaction applications? The person who is asking that is saying that they're anticipating that the overhead of VMware is expensive and uses too much CPU for CPU-intensive low latency operations.
Yeah, so this is basically the question of the holy grail of virtualization, whether virtualization is or I would say operating system virtualization, whether it is needed or can be used in high-end type of applications. So to answer this shortly, yes, there is an overhead of the VM. However, with the Giga Spaces XAP platform, one can decide that this overhead is too high and not to deploy the application on top of a combination of virtualization technologies such as vSphere and VMware and strictly use the VMware XAP. All the dynamic capabilities except for starting new machines on demand are there. However, in less extreme cases, the combination can enable a more cost-effective approach towards using only machines when they are needed. So, I mean, both options are available. The solution doesn't mean that we always support usage of virtualization. In some cases, it doesn't make sense. However, the Giga Spaces product platform shields you from changes in the application and in the configuration. We see in our test that on a tuned system, the overhead can be minimized. However, still running multiple machines on multiple virtual machines on one physical machine has its cost.
Okay, so the next question is, what will be the name of this new product?
So this is it's a good question. It's not final yet. We will announce it pretty shortly. So stay tuned for that.
Okay, the next question is it possible to set up a clustered file system and scale it at the same time than the rest of the cloud?
If I understand this question correctly, out of the box, we do not plan to support file system abstraction on top of Giga Spaces. However, there are several implementations of scalable file system on top of Giga Spaces. Technically, it's pretty straightforward to do so. One that I recommend on reviewing is the file system abstraction in the Compass project. In this case, this abstraction enables storing in a very scalable and efficient manner Lucene indexes on a file system. So you can. It's an open source project. It is driven by Shai Banon, who is our Director of Technology. So many of the ideas there are exactly what is referred by scalable cloud file system. However, at this point in time, we do not have plans for the short term to implement the file system on top of Giga Spaces, although technically it's possible and simple to do.
Okay, the last question we have is what's the difference between the GS agent and the GSM?
Okay, so the GSM is responsible for deploying applications and monitoring those applications and making sure that the initial application SLA is met. The GSA is a more generic process running on every operating system, which controls all the Giga Spaces services, the GSMs, GSCs, lookup services, transaction managers, making sure that they are alive, controlling their SLAs as well. For example, if we want to make sure that there are only 2 GSMs in a cluster, the GSA has a distributed algorithm to control that. I would guess that a more confusing question would be what is the difference between the admin API and the GSM, because basically many things that the GSM can do, the admin API through the agent and through other capabilities can do as well. So to answer that, the admin API is going to be, going forward, our approach to SLA management, and the new SLAs that I've described in the presentation are going to be available through the administrative API capabilities.
Okay, we just got another question. What is missing from vSphere which requires Giga Spaces for the application?
Okay, so I think this is the question that we've been asked many times, and this is why we came up with this solution. So if you consider vSphere is focused on the machine level and operating system level, which means that basically you can start and stop machines, you know their CPU memory. However, there is no notion of application, of what's going on in the application. In addition, vSphere doesn't support or doesn't provide data capabilities like in-memory data grid or event processing or parallel processing. We think, and not just us, that these cloud middleware services are essential for building applications on the cloud. So it's not that vSphere is missing. I would phrase it a little bit differently. vSphere is focused on the infrastructure as a service capabilities of the cloud. And Giga Spaces is more focused on the platform as a service capabilities and the middleware services. And a combination of both enables building cloud-ready applications today. And to put it very simply, this combination that actually stemmed from various Giga Spaces and VMware customers enables taking advantage of both technologies to enable moving more and more applications into the private cloud, and bottom line, saving costs today for the IT organization.
Okay, so at this point, I'd like to thank you, Guy, and the audience. We're going to end our webinar. We would appreciate it if you could please fill out our survey. And please know that in a few days, we will also send you a link to the recorded webinar as well as to the Q&A. Thank you and have a great day.